There we go. Right, we're live. Hi everyone. Welcome to another coding club. Excited?
Yeah.
Cool. Right. So I'm Stephen. I'm a developer. I'm a software engineer at Redgate, and this is
Olivia.
who is helping us out today. We've also got. Sorry. Oh, you ready? Okay. And we've also got Piers who's helping us out on support today. So if you have any problems, give us a shout, and we'll try and do our best to help you out. Okay, that did not work very well, so apologies. Right, I have no idea how much that you heard and how much you didn't, so I'm just going to start the spiel again. So, welcome to another coding club. My name's Stephen, I'm a software engineer, and so we have Olivia helping us out. Yes, I know you're enjoying the fact that the mute was still on. And we've also got Piers helping us out and support as well. So hopefully you can hear me. Take two. Right, so we're going to be looking at where the International Space Station is. So the instructions we'll be following will be, when I can find the chat window, which is again moved. Every time I get this all nicely set up, it all moves. Right, more chat. There we go. Right. I should learn every week that this happens. So I get it all nicely set up on my screen and then it all moves as soon as I share my screen. Right, there we go. So there's the link to the instructions that we're following today. So what we're going to do. So basically you've got the International Space Station, and that's flying around with a number of people in space all the time. And this project, depending on when you run it, the answers will be different. So the screenshots used on the Raspberry Pi website are at the time when Tim Peake was up in space. Do you remember Tim Peake? The British astronaut went up to space. You saw his capsule when it landed in Peterborough Cathedral. And it did a tour around the UK, doing multiple cities. We took a photo next to it. That one. So these screenshots from this instructions were taken then. So you'll see a mentioning of Tim Peake quite a fair few times. But the answers we'll get today will be different because obviously there's different astronauts in space. So at the moment, if we run this example here, we can see that the International Space Station hit run again, see where it is now. So the International Space Station is just literally going over North America at the moment. And it's currently saying that, there's you.
Thank you.
Yeah, do you want tissue?
Yeah.
So it's saying it's literally just gone over North America. And funnily enough, on this example here, the dot is Houston. And it's saying that the next time the space station will go around the world and come back again will be in an hour and 30 minutes of this recording. So also down here we can see who's in space. So there are 5 people up there at the moment.
Is that actually true?
Yeah, that's true. This is all taken from live data. So you can when you run this at different times. So right, so at the moment, yeah, there's 5 people in space. And so let's get starting, shall we?
Yeah.
So for this one here, the starting page you want to use is this link. So it's rpf.io/IISS-on.
I'm gonna put this tissue.
Yep, fine. So I'll put that link in the chat as well. And when you click on that, that will very nicely give us a starting trinket, which will have a couple of things added to it. So the important parts on this trinket is these imports for JSON, turtle, url-lib.request, and also you'll see up here the picture icon has currently got a bit of a grey colour to it. And when you click on it, you'll see that you've got a number of images for the ISS, International Space Station.gif, a second one, and a world map GIF. Yes, I can make the text bigger. I do apologise for not doing that earlier.
Huh? Why did you not do?
I hadn't made the text bigger yet, so someone just quickly asked as well. So these are the images that should be in that trinket if you use the link I've just sent. So if we go back here and make our screen bigger. Thank you for rabbit attack. Okay. Okay, so give everyone a moment to get that sorted. Okay, and it also gives me a moment to set my instructions back to the first page.
What?
I was getting my instructions back to the first page in preparation. Okay, so first off, we want to find out who's in space.
Me.
You're not in space at the moment.
Why not?
Well, if you are in space, I'd like to know what you're doing down here because I'm not in space. Okay, so basically what we're doing is we'll be getting some of this information from, oh, I can send the trinket again. Yes. So, right, so this is the link to the trinket that we're using. That gives you the starting stuff. If you're still stuck on the image part, if you click over here on main.py, and that takes you back to your code. Okay, so hopefully everyone's got themselves sorted. Right, so for this one here, we'll be using a web service. So basically it's a web URL, which if I copy this from over here and open up a new tab for the moment. So we're going to be using api.opens-notify.org/astros.json. And don't worry, I will send that link in the thing. So
that's a lot.
It is. And trust me, I had to copy and paste as well. So when we hit that address, which you can potentially see on yours as well now if you wish to click it, this is JSON data literally telling us who's in space at the moment. So in here you can see that main important parts here is there's bits of text here. So like message and then success. So that means you were able to get some information back from the API. Number is 5 because there are 5 people in space. And then there's this people collection here, which tells you the information about all the people up in space. So at the moment there's Chris Cassidy, Anthony, I'm not even going to pronounce that name correctly. I know.
Wait, where?
I'm going to apologise if I get this wrong. Ivanshin? Ivanshin? Yeah. Ivan, Doug, and Bob. Much easier just saying their first names.
Yeah.
Apologies for getting names wrong if I mispronounce them. So this is what we'll be using to get our information from. So if I close this tab and we go back to our code. So to do that, we're going to be using the URL lib that's currently been imported in to our Python. And first off, what we'll do is we want to say URL equals, and then we're going to paste in that address. So if you can copy that URL off the chat, then that will make it a little bit easier for you. Otherwise, I'm afraid you're going to have to type it by hand. So you just need to make sure you get that right.
Type. 10 hours later. Type.
Type, indeed.
It's very long.
Okay, so to make sure this is all working, we then want to say the response, so what we get back from the API, equals, and we're going to use our URL lib dot request dot URL open URL, and you will get good at typing the word URL in this.
Wait, how do you spell that?
Yeah. So that will then call our web service. So basically we've got our address here for what we're calling. We're then using the URL lib to request the information from that web address that we've then passed in. And then for us to actually see something, we're going to say result equals JSON dot loads response dot read. So here we're reading the response that we get sent back, because just getting a response isn't actually reading the information. Just like you buying a book, you're not reading the book until you open it. And then
you could read the blurb, which is part of the book.
Yeah, but I meant the inside of the book.
Ah, the actual story.
Actual story, yeah. So then we're using our JSON library we've pulled in here to load in the information, because this is JSON data we're loading in.
Why is it called JSON?
JavaScript object notation. And I remember that because I knew someone was going to ask that question, and I always forget myself. I just refer to it as JSON all the time. So good question. 5 imaginary points to you.
Ooh,
So we're
what
reading
can I spend them on?
more imaginary points.
Really?
Yeah.
Okay.
So anyway, what this does, this reads in the JSON data so we can then view it in a format that's going to work. So here, if we then do, for the moment, print result, hopefully, if you've got the right address and everything is working, and in this case, the stars align, you should see down here in your trinket bit here that the information that we saw on that previous web page has now come in here. So we can see the message success, number 5, and the 5 people currently in space at the time of this. So So I'll give everyone a moment just to hopefully see if they get information. Again, if you have any problems, what you can do is up here on share, click the drop down arrow, go down to link, copy this URL, and then if you send it to us in the chat, we can click on it and respond to you.
Wait, what about hands up?
Yeah, no one's using that stuff. So I will send you my trinket link for the current page I'm on in case anyone is stuck, and that should include all the bits you need, including the images.
I'm controlling you now.
Yes, don't start multi-fighting mouse clicking.
Ah!
I needed the mouse to go to the other screen for the moment. Cheeky. Right, let's move all that out of the way so we can see on that screen a little bit better. See, now you can see yourself as well. Bonus points.
I was just about to ask that question.
Okay, so fingers crossed. People are starting to see this information. Again, let's say if you have any problems, let us know, and we'll try and help you as best we can. So in here, like we were saying earlier, we've got some information that's come back in this result. So what we can do is we can say, how many people are there in space? Because that'd be quite useful, wouldn't it? So I'm going to comment out this line for the moment, and we're going to say print. We're going to say in here, people in space. And then we're going to say comma, and we're going to go from our result, the information we want to get out of here, from our square brackets, quote. So we want to get the number. So what we do is we result, square bracket, quote, and then we want to match this bit here. So we say number, and then if we run that, you should see people in space is 5. So that's good.
I'm in space. Woo, I'm in space.
So in the example on the instructions at the time of that, there were 3 people in space, but we've got 5. So we've got 2 extra. I do apologize for running into the others. Okay. So next what we do is we can try and get some of that information about the people. So what we can do is say people, and we'll say equals result, square bracket, single quote, and then we want to say people. Close that, and then we'll say print people. Because we want to see that we make sure we are getting information back out of our JSON request. So again, we'll run that. So we then see the people's information here. So we've just got the information here.
That's a lot of information.
It is, but this is the joy of an API. You call an API and you get lots of information back, and then you use what you need. So in this case, we've taken out how many people are in space, and we've also grabbed what people are in space.
I need to go just a little bit closer.
Oh, what make this text a bit bigger?
Yeah.
There, I'll go on like that. Can't make it too big, because otherwise it'll be too big and I won't be able to see it myself.
Oh, make it as big as you can.
Okay, so hopefully you've seen this information on your trinket. Pardon me. So let's do something a bit more, let's make this information a bit more readable, a bit more human. So what we can say, because what we've got here in people, we've got a collection of people. So if you remember from previous lessons, we can do for. So we go for P in people, and then you have a colon, and then again make sure you're indented because of Python using indents, and we'll say print, and we'll say P, and then angle bracket, square bracket, quote name. So that will there get us the name of each person.
Space rabbit.
No space rabbit, I'm afraid. So if we run this now, what we'll do is we'll comment out this people one here because we don't want to see all that text anymore. So we run that now.
Oh.
So now we can see the 5 people in space. So we've got Chris.
Wait, can you take that out for a second?
Take what out for a second? The people bit.
How much?
What? So it's like that, you mean?
What does it mean?
So in here, this is our collection of people. And then if you see in here, there's these curly braces, as we call them, and that's one person there.
Oh.
So here you can see that one person, the information they have is the craft, they're on the IIS, the name, Chris Cassidy. So we've got then the same again, another angle bracket person, another person, and lucky number 5 person. So when we've done this for P and people and to print the name, we're literally getting the name. So we're getting name there, name there, name there, name there, and name there-ish. Yeah. Okay, so we'll comment on that for the moment. So hopefully at this point, you're all seeing, if I rerun that with a commented out code removed, you're getting this sort of information here. So give everyone a moment to catch on that and see if we've got some people who need any help. So again, shout out if you get stuck and we'll try and help you as best we can. Okay, so one person has sent their code. So the problem is here. Oh, I have to zoom out a bit so we can actually read it. So on here.
Oh no, I can't read it.
You've got people in space, result. This bit here needs to say people, which it does. People equals result space. Let's have a look. Result space, where's...
People needs to be result of people. And line 12 just wants to print result number.
Good spot there. You know what, doesn't help, I'm actually looking at the code that I'm trying to debug and not my code. Dear.
True.
Yes, so that should be number. And what was the one you said? Result people, that should be... That should be people, yes. So yeah, that should get you unstuck. Okay. So I will share my trinket, so if people are really stuck, they can also use that. But again, if you do get stuck, let us know and we can try and help you out as best we can. Okay, so I think that's probably a good time to continue. So the next challenge, first challenge of the day actually, is given that we have, if I uncomment out my code again, we've got all this information here about people. So say we've got in here the name of the person and then what craft. So can you get your code to say the name of the person and that they're on the International Space Station, or IS? So we want to get the information of what craft they're on out and print that on screen as well. So we're going to say Chris Cassidy. Oh, don't do that now. Don't do something. So we're going to say Chris Cassidy in and then IIS.
Ow.
But we can't just write IIS ourselves manually because they might not be on the International Space Station. They might be, like there was a couple of weeks ago, the rocket that went and took people up into space.
I have no idea about that.
Okay, so what do you think? We've got this print P name. So remember in print statements we can do a comma, and then we can do single quote and say in, single quote. So if we just run that for the moment, we now get Chris Cassidy in. So how do you think we could then get the craft information on there? No, that would not work. Okay, so we've got this P, and that's a person. Do you reckon we could use that?
We haven't turned it into an actual person.
Yeah. Right, so we've got P person, but remember how we got the name out of person?
So, right, P,
Well, that'd be the name again. We want the craft, don't we? So what we want to do, yeah, no, not quite. So we want square bracket. We want to get information out of there. Single quote. And then we want to get the craft information. So what do you think we say?
Thanks.
You are stretching across quite considerably there. Shall I type the letters?
Yeah.
All right. Okay, so yeah, so if we do, so in your line code here, if you've got print, open bracket, P, square bracket, quote, name, close all that, comma, in, comma, P, and then craft in there. And then if you run that, and we'll quickly just comment out that extra bit of noise at the top there.
What noise?
The extra code from before. So we can see here that they're all on the International Space Station.
Really?
Yeah. Well, at the moment, that's the only craft up in space at the moment.
Oh.
But that can change when people come up and down from space. Because at the moment, there's the, I'm going to call it the wrong name, the Tesla rocket that isn't a Tesla. The one they tried recently.
Hey, Dad. You know when you say Tesla rocket, that's actually Ratchet and Clank.
Mm.
Tesla rocket.
Okay, so what we're going to do next is, that's all good that we can know who's in space and that they're in space on this International Space Station, but what about if we found out where the International Space Station is in space at the moment, or relation to us on Earth? So we've got another URL we can use here for another API. So this one here also uses api.open-notify.org, and this is the is-now.json. So that is where's the International Space Station right now? And if we run that, at this very moment in time, it's currently at these coordinates. So latitude 41, longitude 3, timestamp, and that's a Unix timestamp. That's how many seconds since the Unix epoch, I think is the right, what's the name of that? But basically we want to turn all this information into something that we understand, because
like a map.
Yeah, because at the moment I couldn't tell you where 41.6 and 3.0 is on the world.
Well, I think it's about like over this other universe or something like that.
So if we close that, and I will send this link to everyone, so you don't have to type it in yourselves if you can copy and paste. So what we want to do is we want to get that information into our code. So what we can do is we come down here and make sure we unindent. So back at the start, and we'll say URL equals single quote and that address I just put on there.
Because you forgot.
No, because I copy and pasted because I'm not typing that by hand. Addresses like that are very easy to mistype, and if you mistype them, you'll be wondering why it doesn't work. So if we then, from that URL, we then want to do like earlier on, so we want to load the response. So we can say response equals urllib dot request dot URL open bracket URL. So if you remember from before, we've got the response. We now want to get the information, so we need to read the book effectively in our metaphor. So JSON.loads response.read. So that brings back the JSON information in a format that we can read. Make sure you do open close brackets there, because I just forgot. And we'll print that response on screen to make sure that we're working. So for the moment, if we run that code,
nothing will happen?
Well, thankfully something does happen. So we've got, from here, we've got the information that we just saw on the screen earlier. So we can see that the International Space Station position and its latitude and longitude.
But we still don't know where it is.
No, that's fine, because at the moment before we were visiting the web page to see the information. Now we've loaded that information into our code, so we can now do some magic with it. So what we next want to do is make our life a little bit easier. So like before, we stored the people into a people variable. We're going to store the latitude and longitude of the space station, so we can easily use that for our next stage. So what we want to do, we'll get rid of this code for the moment, or we'll just comment it out, we can do. So we'll say location equals result, square bracket, single quote, ISS underscore position. So make sure that this here matches this here, because otherwise it's not going to work. So that gets us the location, and what you'll see here is our IS position contains an object of latitude and longitude, see, because there's curly brackets there.
But I don't know what that is.
So we've got something that says location, and inside the location it has a latitude and longitude.
Still don't know.
That's fair enough. So it's just basically we need to go into the location to find out extra information.
Wait, so basically we have to go to that part of the world so then we can...
No.
so then we can know.
So what here is we'll get the latitude. So latitude is often referred to as lat. So we'll say lat equals. Now we need to convert this into a number, because the moment when we read this in, it's a string, it's text. But we need this as a value that's, you know, a number. So in this case, we want it as a float because it's got decimal points. So we say float, open bracket, location. And then for this one, we want square bracket, single quote, latitude. And then close all them. And then we want longitude, so also known as long. So we do the same thing, so float.
Cool. I'll get like a glowing cup.
Location, square bracket, single quote, longitude. close that again, and then to make sure this all works, we're going to say print, and we'll say latitude, lat, and then print longitude, and that on. So if we run that, hopefully, there we go. So we've got the information out. So we've got the latitude, which is 30.004, and longitude 19.4638. And
We still don't know where that is.
no, we don't, but we've now got that information so we can use that.
Wait, is it like right here on the shoulder?
Yeah, not quite. So effectively, we've gone and got the big load of information that we got from their API, and we've got drilled down to the little bits we need, and then we can use that information to find out more.
This is our world. We're gonna go into the space now. Whoa, so cool! Like a big giant room.
So hopefully at this point you're seeing something very similar, and I will share this code in case people are stuck. But again, if you do run into any problems, if you let us know, and we can try and help you and debug your problems. So at this point here, I think we should introduce the turtle again. So
I've got
up
an
here,
idea for that.
we'll go in import. I think Nick, I know what you're going to do. So go import the turtle.
Does it have the bunny
So up
rabbit?
here
It's
we've got
already
outline.
imported.
Oh, it is. Yes, thank you.
Huh?
It's already imported. It's actually already here on line 4. Stop putting the bunny on me. It's hard to take. Right. So yes, we've already got the turtle. So before I get distracted again. Right. So on here we've got the turtle. So what we next want to do is we want to show this information on our little output here. So what we can do is, my instructions seem to have decided to slightly go off. So we're going to do is start doing some stuff on here. So we'll say screen equals turtle dot screen. Yes, I can make it a little bit bigger. There we go. So we're going to get our turtle set up. So we're going to say screen dot setup. No, I've actually skipped a step. I should be doing screen.
Hey Dad, I found the turtle.
Yeah.
Who's
3 E's in screen.
Sorry. Oh yes, there is.
Yeah.
It's a screening screen. Thank you for the spot.
I know you lost the turtle, so
Yes.
I found it.
Very good. Thank you. I knew that's what you were going to do. Right. I'm getting distracted and losing my flow now. So screen.bgpic. So that map that I said we had earlier. So open quotes map.gif. And I think if I'm not being distracted, I run that. Hopefully you should see a world map over here, which I will have to resize my screen temporarily just so we can actually see that. Reset and rerun that, and hopefully it should show a bit better. Okay. But at the moment you will probably end up with slightly similar where it doesn't quite fit on your screen, but that we're going to correct in a sec. So yes, Lydia. There you go.
Thanks.
Okay, so we've got a world map. So what we want to do is at the moment the world map is centered around the 0,0 position on here. So to make our lives a little bit easier and also make the image fit on screen, we're going to do a little bit of manipulation. So on here, after screen, with 2 E's, we're going to go screen.setup, and we're going to say 720 by 360. Oh, I'll do 360 now. Press the 3 myself. Right. Yes, I will send the code in a second. I will just get this next bit done because this will help make sure everyone's in the right spot. So
You've put set IP.
I have done. I did. It's one of those days where I'm just literally hitting every wrong button. So I've hit 2 instead of 3, and I've hit I instead of U. Right, screen.
I know you
Breathe.
do this.
Yeah, don't. I don't need your help to make more mistakes. I can do that on my own, thank you. So we're
I
gonna.
can help you.
Alright.
Like you said.
So at the moment we've set screen.setup and set the size so we can make sure that the world map fits on there nicely. And what we're going to do is we're going to position the world map so that the 0,0 of latitude and longitude is the correct position on the map so that we can kind of cheat a little bit here. So if we say screen.set world coordinates, and I'm saying it like that because I'm sure I'm going to spell it wrong, coordinates, open bracket, -180, comma, -90, comma 180, comma 90. So that's just going to stretch that out. So we've got minus 180, 90 down to 180, 90. So if we run that,
You got an extra I in coordinates.
you know what? It's just not my day today. I really.
You want a turtle hug?
I might need one. Coordinates. That I there. Right. Let's run that. So now you should see, hopefully, and if I resize this back to 100%, so you should get a nice world map that fits on there quite nicely.
Turtle hug.
So I'll scroll it back up a bit, and I will now send the code because even I am having fun with typing today. So if you end up finding out that you cannot spell or have the type and hit every single wrong key syndrome that I have today, there's the code that should get you to a position that works.
I didn't have it because I can't type fast.
It's partly practice, partly also difficult because we're teaching, so we've got to make sure that we do stuff as we can. Yeah, I don't know what you're typing, so just be careful doing that. Oh, doing that. Right, let's get that out of there. I don't think people want us to write HG into chat. Okay, so hopefully you've got your code. Hopefully you've got your world map. Again, if you do get stuck, or like me, you managed to type everything wrong, let us know and we can see if we can debug you. Because these parts that we need to get are important for the next stage, because we build on top of that. So I think the next step is we want to get the world map with a International Space Station shown on it.
Yeah.
And we can use a turtle for that, can't we? Not that turtle. I know you're saving that. You know what? I'm glad I didn't tell you that the turtle was involved until last minute, because I'm sure you would have even worse, more turtle jokes.
I just can't. I think this is gonna be totally great.
Very good. Okay, so let's continue on.
I shall.
All right, stop now. Okay, so what we need to do is we want to set our turtle to use the International Space Station icon that we have. So if you remember on the picture here, we've got our world map, which we've just used. And we've got the is.gif1, is.gif and is2.gif. So this is where you can choose which one you want to use. Yeah, I definitely think there needs to be a disclaimer on the jokes from my daughter.
Huh?
Piers just said, apologise for your jokes. Dear. Right, I'm going to all over the place today. Right, so what we want to do is we've got the world map. So down here we want to say screen.register. I want iss.gif.
You know what's funny? It's really funny.
Oh, it is. Oh, and I've mentioned my single quote. I'm really doing terrible today. Single quote iss.gif, single quote, close bracket. So that registers our image so we can use it. And then we want to say the International Space Station, ISS, tongue-tied as well, equals turtle dot turtle, open close brackets. So small t at the start, big T on the second one. Definitely important, otherwise you might find out you're not going to get it working. And given the way my things are going today. So then what we want to do is iss.shape, and we're going to set it to be that ISS GIF from earlier. So from that, we then want to make sure it's facing the right direction. So we're going to say iss.setHeading. And we're going to set that to 90 degrees. And then the most important part of all this, iss.penUp, because we don't want our turtle drawing all over the world map. I really cannot type today. Thank you. And then ISS. No, it's not. That's right. So if you remember from our earlier turtle stuff, we can make the turtle lift up so it doesn't draw as it moves, and then we're going to tell it to move. So we're going to tell it to go to, and this is where we can then use our coordinates from earlier. So lon, lat. Now this is important. Normally it's latitude, longitude when we're talking about the world map coordinates. But when we're talking about moving the turtle, it uses X and Y. So they're kind of flipped over. So for this one here, we need to make sure we say lon, lat. Otherwise, you're going to end up with your turtle showing the ISS in the wrong place in space.
No, you've actually got to say Iron Man.
All right. Right, so if we run this, hopefully, what have I done wrong? RIGIST. Oh, it's register underscore shape. I do apologise, everyone. Right. So to run that, fingers crossed. So you just saw there, our International Space Station appeared on the world map. And if we run that, we'll see it's currently just over Africa.
So on this, where would it be?
That's North America, there Africa. So it's just off the coast of Africa there. So I'm going to share this
So
code because,
tiny.
yeah, what, the world or the International Space Station?
International Space Station.
I say, because the world is big and the space station, yes, it is small. So this is the update code, which should give you the International Space Station on a world map.
It's tiny still.
It is tiny.
It is so small.
It's a lot tinier than that though. That image is quite big. I mean, that's, if you look how size the UK is over here,
It would be bigger than the UK, like the
Yeah.
whole UK.
Yeah.
would
the
be
space station is not that big.
Yeah.
I'm sure it is in 100 years' time, but at the moment it's not. Okay, so the other thing is, if you wanted to, if you change it here to be ISS2.gif and same here on line 39 to 2 and run that.
Wait, can you
That'll-
smaller than the image? Oh my, what?
So you can, if you wanted to use a second one, you can change that to be 2 for both those lines, and that will give you that one.
I want the red-eyed.
I know you do, and I figured you would. As soon as I saw it, I was like, yep, that's the one you'd choose.
Why?
Because I just know you. I know you very well.
Why?
Because. So we'll give everyone a chance to catch up and make sure they've got their International Space Station.
She'll kill them now.
And if you keep running it, you might notice
Okay.
that it, well, at the moment it hasn't moved much more from there.
Oh.
But it depends on how much updates. But remember at the start of the session, it was over here, near America.
And it was not the red-eyed one.
It wasn't the red-eyed one, no.
How do you know? How did you know?
The power of being your dad.
Ah.
So run that again, see if that's...
Oh.
So 46.94. So yeah, if you ever look down here, you'll see, thank you, you'll see down here the latitude and longitude each time you run it is actually changing.
Really?
It is, yeah.
I can't see it.
Well, it does change down here.
Really?
It depends on how often they update the information because they don't update every second.
Oh, I think I know how you knew that I want the red-eyed one. Because it's got green on it, and the blue one doesn't.
I don't want to tell you all my tricks.
Huh?
Okay, I don't want to tell you all my tricks.
Can you tell me the tricks after the video then?
No, I mean, I don't want to tell you all my tricks. You'll know all my tricks.
Hmm.
Okay, anyway. So at the moment, that tells us who's in space, how many. Sorry, how many people are in space, who's in space and where they are, which at the moment is the International Space Station, and where that is currently in relation to the Earth. Well, where it is in relation to the people on the Earth. So run that again. It's moving, as you can see, it is slowly moving away from the coast of Africa. So tell you what, in the next 5 minutes, I think it'll be over Australia.
He does.
Given that it's sort of running on that line.
He does.
Yes.
I think this is hoppingly exciting.
Very good. Okay, so the important question next is, when will it next be over us?
Oh, that would be like 2 million years maybe.
Maybe. So if we go down here, and what we'll do is we'll say, now in the example on the Raspberry Pi website, they say the Space Centre at Houston, which we can use, but I thought given that we're based in Cambridge, why not use Cambridge?
You're cracking me.
I'm good, I know. So one of the things you probably want to know is, where is Cambridge coordinate-wise?
I need to go to my egg cup.
So what we can do is, using things like Google, you can type in Cambridge latitude, longitude, and very nicely Google comes back telling you the answer. So it says 52.2053 north, 0.12818 east. But these are GPS coordinates. So if someone wants to use their own local town, so, you know, if they live somewhere else, like, I don't know.
America?
Well, we could do, I mean, let's say, I know, where I grew up. Knox, Knox City. I spell Australia today. So there you go, where I grew up. So you can use those coordinates if you live in Knox City, or thereabouts.
Oh,
Steve Knox.
oh, what about here?
Well, I was going to do Cambridge. Cambridge is pretty much a good one because it's a nice big city and it probably covers the number of people watching, unless people in America, in which case Houston might cover it better. Anyway, so these coordinates are what we're going to use. So if we go back to our trinket for a moment, I'm going to say Cambridge, UK, because there are other Cambridges in the world.
I'm getting getting hard boiled.
So latitude equals, and for this one we said Cambridge was at 52,205. So
Hey Dad.
Yes?
This reminds me of a joke.
Okay, well let me do this bit first for a moment, because don't want to get.
It'll be funny.
Okay, well let me do this bit. So 52,205, and the longitude from there as well was 0.121.
Let's show it now.
In a sec. Let me get the Cambridge dot on there, and then you can do it. Okay. So these are the coordinates for Cambridge, UK. Again, if you want to use somewhere else, you can. Make sure you've got your latitude and longitude numbers in there. And 3 decimal points is probably enough. You probably could do 4 if you really want to, but 3 will do enough for example.
No.
Not yet.
No.
So, so location equals, I'm going to tell the turtle, we're going to use this as a turtle. And we're going to say dot turtle, brackets. We want the turtle not to start drawing on the map when it's moving. So location, well you can do, but I think that's something you can do there. So pen up, because we don't want to draw. We will then want location dot color, and we're going to use yellow. So this is going to be a dot on the map that we're going to make so we can see where Cambridge is on the UK in relation to the world map. So that, and then we want to say location dot go to, because we want the turtle to go to the location. And remember, we've got to do this in the opposite order. So we want lon, comma, lat. And then we want to say, we want to put a dot on the screen. So if you remember from our turtle stuff, we can say location dot dot. And we want a size 5, so it's big enough that we can see it on screen. And then we want to hide the turtle. So go location dot hide turtle. Close. Now if we run that, oh, I made a mistake. I've got capital T for turtle, so small t. There you go. There we go. Because code is case sensitive. So in their code, hide turtle is small, all lowercase. So there we are. We've now put a dot on the world map where Cambridge is. Ta-da! And as you can see, the space station is now moved over, but much further off the coast of Africa now.
Can I share my joke?
Share your joke. Give everyone, well, let everyone get a chance to catch up and get their code to this point, and now you can tell your joke.
So in a school, a teacher gave everyone homework, and they didn't really like it. So they said, "Why do you have to do homework?" Because you have to learn at home. And then the teacher said, "Don't worry, this one will be a piece of cake." That's why the kids ate it.
Very good. You've been saving that one.
Yeah.
Okay, so hopefully everyone's had a chance to get a dot on the world map for the location they chose. So again, if you want to use Cambridge, these are the coordinates. The ones for Houston, I can also copy onto the screen if people would like that. So what I'll do is I'll do just copy here. Hash Houston. Space Center. Yeah, can't even spell Space Center now. And latitude equals 29.5502, and longitude equals minus 95.097. And yes, I'm reading out the screen, there's no way near that. So if I comment out the Cambridge one for the moment and run that, very quickly you'll see the dot will move over here. Ding, there we go.
What dot?
So that's the space, that's Houston Space Center in America, North America, US. So that just shows that we can do that. So we're going to comment that one out for the moment, and we'll do the Cambridge ones there.
Did I do like my new hat?
I do like your new hat. Right, so I'm going to share this code as we're up to at the moment, because we're on to the next stage. So we've got a dot on the world map for where you want to know where you are, or where you want to know about where the space station's going to be next, but we haven't got that information. Now, once again, we're going to use another API, and for this one, copy this link address, get rid of that. So if you paste this one, what we're going to use is is.-pass.json. So this one here will let you know when the space station is going over a particular location. So if you run this one, you will see quite quickly that it fails. So you see here message failure. So before we've seen message success for everything else. And this one here says that you haven't specified a latitude. So what we need to know is part of the address here is it's asking for a latitude and longitude. So here's one I copy addressed earlier. So here you'll see that we're passing in a query string, so that's what the question mark is, a latitude, and then the latitude coordinates, so 29.55, which will be Houston, and longitude of 95.1, I believe that is all Houston. Familiar? So if we run that one, it will nicely tell us that successful message, so we got the information back, what we requested, and when it next will be over. So this is when it will come over and bits of information. So the important part here we need to know is the rise time. That will tell us when it's next coming over and be visible. If it was dark, you might not be able to see it with the clouds that we've got at the moment and or the sun being up. So what we want to do is we want to bring that information back to our stuff so we can work with it. So if we close that for the moment. So if we scroll down here again, and I'm going to make this a little bit bigger. So we're going to say URL equals, and I'm going to paste in my previous bit, and I will send the link. So this is a link to the API. And if you do click that, it will give you that error message we first just showed. But yes, so what we do, we've got the URL for that address. We're then going to say URL equals, and it's going to equal itself, so URL plus, because we want to add more to this string, single quote question mark, and we're going to say lat equals, then close the quote, then we're going to say add, and we're going to go str latitude, because at the moment our latitude is stored as a numerical value, and we need this to be a string to be adding on together. And we then want to go plus str, oh nope, no we don't, we want plus, and then we want single quote and the and sign, so shift 7 on most keyboards, lon equals close single quote plus str lon. We'll send this code in a minute if people need it. So from that, we've now basically built what we call is built up an address. So this is going to hit this API with those information that we need. So for us, that'll be the Cambridge UK stuff. We then want to say, as before, response equals URL lib dot request dot URL open brackets the URL that we've built. We then want the result, so result equals json.loads response.read. So this should be quite familiar from before. Close brackets. And then what we do is we want to get the information when it's over us. So we'll say over equals result, square bracket, single quote, response. Then we want square bracket 1, because we want the first one, because when we saw before there was a bunch of information in there that was all coming back. Actually what we'll do is, to make it easier, we'll show that on screen so we can see. So we'll go print result, we'll run that, and we should hopefully see that information as it comes back from our API. So here you are, you can see the information that we saw earlier. So for this one here, it's the Cambridge information we're seeing. So success, we've got the information and all this stuff here, and then in here there's a response. So this is the response bit we're going to pull out in a second, and then in here is a collection of the time it's going to arrive and over the top of us. So here on line 66, if I can comment that out, we'll say when it's next over us, it's going to be result, this response stuff, and we want the first one, and then we want the rise time.
Oh, like waking up time or something.
Kind of, because you think about it, the space station's going around the world, so it is effectively, to us it appears, it's rising over the horizon. Okay. So we'll see it come up from the horizon, effectively, if it goes over the top of us exactly, going over us and then off into the horizon again.
Okay.
And that would be the set time, effectively.
Mm-hmm.
So like sunrise and sunset.
Mm-hmm.
Okay, so if we then do, we've got the information there and we want to say print over so we can see when it is next over us. So if we run that now, oh no, we'll comment, I should have commented that. So we'll get rid of the extra information and run that again. So you see here, it's next over us at 159257840. And as I don't speak that sort of time, and I don't think anyone else probably does, although I could be wrong, that's not really useful to us, is it? So what we want to do is we want to translate that into a time that we can all understand. So at the very top, we're going to go up here, and in the import, we're going to import time. So time is a library that helps us convert time from different formats. So we want to convert it from the standard format, which is basically unhuman legible, if that's even such a phrase, and we're going to turn it into something we can actually use. So down here, what we'll do is, and we want to print this on the screen as well, because it'll be nice to have it on the world map rather than having it down here. So what we'll do is we'll comment out this print over. And if you are following the instructions on the Raspberry Pi website, the image they've got on there actually does have a typo on that one. It doesn't have brackets around over. So bonus points if you spot that. So what we'll do is we'll say style equals. So if you remember from our previous experiments and stuff with Turtle, we can set styles. So we can set, we want to use Arial font. We want to use it size 6, and we want it to be bold. And what we then want to do is, that's a good point actually, that doesn't, yep, that's fine. So we've got to style that, and then we want to put the location of that. So we say location dot right, and then we're going to go say time dot ctime over. So what that's doing is that's converting that over that time that we've got stored in over, which is this information here, using this conversion function to give us a time that we can understand. So yeah, so then comma, and we're going to say font equals style. So again, if you've changed your font to be a different color, then obviously it'll be nice. So if we run that now, we should, fingers crossed, space station, dot for Cambridge, and the next time it will be over Cambridge at the time of this will be on the 20th of June at 7:03 and 39 seconds in the morning. So there you go. So if you're up at 7 o'clock in the morning and you look up, you might just see the International Space Station. But given how much daylight there'll be at that time, it might be a bit difficult.
Yeah.
So that is pretty much a lot of stuff to digest in one hour session. So one of the things you could do as a challenge for yourself is maybe put down different locations to sort of say where it is over somewhere else. So, you know, if you know somewhere in Australia, like Sydney maybe, or, you know, America, you know, then you can put bits down there and see when it will next be over those locations. So I'm going to share this code as we've got at the moment. Oh, that's fine. Yeah. So yeah, if you've got any problems, if you've struggled with any of that code there, if you give us a shout, we can try and help you out. Otherwise, give yourself, you know, maybe try that challenge and see if you can put down extra cities or places that you want to sort of know when the International Space Station will next be flying over. And as I said, I wasn't too far off. I said in the next 5 minutes it'll be going close to Australia. It's going over that way a bit.
Right, it's been 5 minutes.
Well, it's been probably a bit more than 5 minutes now. But you're quite pleased with that. We've turned it, something saying about where the International Space Station is in coordinates that we don't understand off the top of our head, in a timestamp we don't understand, into something a little more human friendly and visual.
Why do you have to make it so complicated?
Because a lot of these systems need to understand stuff like that. So the world's been mapped in using latitude and longitude coordinates. So if you use GPS on your phone, especially for like using sat-nav, you know, or you know, Google Maps and other stuff like that, that's how we can tell where a certain location is, because a computer doesn't really understand where Cambridge is so much, and there's a lot of places called Cambridge.
Really?
Yeah, there's a number of places called Cambridge.
Like,
There's a number of places called Perth. You've got Perth in Western Australia, and you've got Perth in Scotland.
okay, what else?
Oh, well, there's loads. I could be here. I mean, Springfield is. That's another one. So yeah, so to make things like that less complicated and less chance of being a mistake, there's the latitude and longitude coordinates in the world, and from that you pretty much know where it is. And the more points after here, the more accurate it is. Because 45 is a big area, 92 is a big area, but 207 is shrinking it down to a small area.
Not like this small.
I think if you do the full stuff with GPS, you can get it down to about 7 meters area, which is quite small if you think about how big the world is on its own. That's quite clever. And yeah, obviously for a computer, that's helps it know where it is, but obviously turning it back into a format that we can understand is where extra work's required. So a dot on the world map for where Cambridge is.
Yeah.
Yeah, very good. Thank you.
Shoulders.
Okay. So yes, we've got some people here just sending in their code. Unfortunately, when you send it through the Q&A part, we can't click the link or copy it out very easily. But I'm guessing you beat me to it there.
Huh?
Piers beat me to it. I was going to try and answer the question, but he beat me to it. So I think that's pretty much just the end of the lesson there. Thank you everyone for attending. I hope you've found this useful. Again, if you've got any things, send us the feedback. It'd be great. Oh, we've got one person who's saying they can't get this working. See if we can quickly debug that before the end. Let's have a look. Okay, so if we copy that across, I can hopefully show that. Oh, let's shrink this down a little bit so I can actually view on screen. Okay, so it's saying here unexpected token JSON. So that kind of implies that the address might be a little bit out. So here we go. If we look at, oh, so move your controls out of the way, please. I can't click my stuff if you're in the way. I was trying to look at my code so I can. So down here on your address here, you might need http://api.open-notify.org/is-pass.json. That looks about right now. I think that should work. If we run that. There we go. So yeah, it just looks like you're missing the http:// at the start there. Someone's asked if the code should work on a normal Python window. I believe so. I must admit, I've not tried it outside of Trinket, so I do apologize.
I just tried it. Seemed to mostly work until it got to trying to load the picture for me, but I didn't download the pictures.
Fair enough. So you were all about to me. I still haven't got Python working on my machine yet. It's on my list of things to do. But yeah, I think that's pretty much taken us up to almost over our time. So I hope everyone's enjoyed the lesson. Do send us your feedback if you know how you found the lesson, because we do appreciate hearing about what went well, what didn't. Because we're still learning.
Muting yourself?
Yes, I muted myself for the first few minutes and didn't realise. So yeah, thank you to Olivia for helping. Thank you for Piers for helping out again as well, and especially spotting all my bugs, because I think I've done more than anyone else today.
Even me.
But yeah, so yeah, hope everyone's enjoyed themselves and hope you all have a good weekend. I'll leave the session open for a few more minutes if people have any questions or need any help. But otherwise, see you next week. Thank you.